do all of these graphs qualify for what we wanted for question 5? Do all of them work? Do all of them qualify? Okay, look at them carefully. Look at them carefully. There is an arrow pointing to the left of -2 on the problem on the bottom left. Okay, this one right here, there's an issue on that. It would be correct if it went like this, or if it was a point to there. That's correct. But since there's this arrow to the bottom left, it does not work. With me on that? Make sense? Okay, be careful when you're doing this. You have to stop after you draw it and make sure that that domain in the range is accurate. Okay, make sure it connects to the graph perfectly when you're doing these. That's a difficult thing for students to do, because once they feel like they've gotten something correct, they just write it down and they're like, I'm done. Right? What you don't do is you don't go back to verify that it's accurate. You don't pause, take a double check at it, okay? Because part of the reason is you get frustrated and you're like, oh, I'm done. Oh, that looks good now. Okay? That's part of it. The other part is you're just not that detail-oriented. Okay? You got to get there. You got to verify that. Put your phone away. And pull it out of your ear. Unless you want me to keep those. Okay. I didn't think you did. Okay. Okay. Next version. I'm going to take a look and I'm going to pull up your second graph and then we'll talk about the ones on the back. So, pull up. Here's a. You know what? That email didn't come through from my phone. Anyways, we'll just stop there. Let's go to the back now. Okay, let me coach you through this problem. Let me coach you through drawing it. Okay? I just want to coach you through, and then I want you to draw a different version of it. Okay? I want you to draw a different version of the one that I draw. So do not copy down the one that I draw. You with me? Do not copy down the one that I draw because I want yours to be different. Okay? Okay. So here's what we're doing. We want to do the same domain range, x-intercept, y-intercept from the first problem that we did in class. Okay? So what I'm going to do is I'm going to say domain. The furthest left is -5. We actually can't get to -5 though, right? You see that? Domain is how far left? The furthest left? The furthest left is really close to -5, but not there. So what I'm going to say is I'm going to just draw a dashed line and draw a dashed line at -5. And I'm just going to say we're getting close. Okay, we're getting close to it. Okay, so I could also use an open circle to signify that, right? That's one way that we show it gets stupid close to it. Right? I'm just making some notes right now so that I can kind of get an understanding of where I'm going with it. Okay? I am also going to the right forever. Correct? The furthest right is to the right forever. So I'm going to put arrows on the graph to kind of say, outside the graph, to kind of say I'm going to the right forever. I'm keep going. Okay? Let's look at the other information, the range. The furthest down is -2. But I don't get to -2, so I want to open circle. Okay? I just get close to it. And it goes up to infinity, so I'm going to draw some arrows on the outside of the graph to indicate that it goes up to. Okay, kind of goes up forever. I'm just doing that, make some notes so I don't have to think back much. The other things that we know that are 100% certain on this graph is that the graph has to go through -3. 0. Okay, and that's the only x-intercept that the graph actually goes through. Okay, we also know that the graph goes through the y-intercept of 2. And that is the only y-intercept spot that the graph goes through. Got me on this? Now, it's open, and we have to draw a graph that just fits those characteristics. We can get a little funky with it, okay, but it has to fit those characteristics. Here's the thing. Notice how I have these two arrows on the far right, top right? They're going to the right and up forever at the end. So I'm going to cut to the chase. Since it's to the right and up forever, I'm going to actually draw this as part of my graph, an arrow that goes up and to the right forever. You with me? So I got the infinities part checked. Does that make sense? Just threw that in there. Now I got to make sure my graph goes through these two dots, and only those two dots on the x and y intercept. So I'm going to do some squigglies. Ooh, there. Got a little funky, right? Then I'm going to come up here, go through there. Sure. It qualifies for all of those. What we haven't dealt with is the fact that it can't get any further than -5, and it can't get any lower than -2. Okay? There's two ways. There's really only one way I could do that, or a few ways, I guess. We could come down and just say here, and it gets that spot right there as an open circle, which means it got really close to both of those two dashed lines. You with me on that? That's one version. You can make it a little bit more funky. Okay, that's one version. I can change this very end part, and I could say, oh, let's do this. Let's come all the way over here. Let's have an open circle right there. And then let's come all the way to there. But we can't cross the y-axis and do that. That's fun. That works. Right? That works. Actually, technically, I should make this go back up here a little bit, technically. But I'm not going to be super specific, because if we don't come back up here, we're actually not at -1. If we don't like cross -1, you know what I mean? Because then it's not in the graph, and then our domain range is messed up. Okay, here's what I want you to do. Draw a graph that works right now. Draw a graph that works. Okay? After you've drawn a graph that works for that, whatever you feel like looks great. Okay? You can make it funky, you can make it boring. If you're a boring person, make it boring. If you're a funky person, make it funky. I'm funky / awesome, so my graph is funky and awesome. Okay? So go ahead and do it. After you feel like you've got that, you can ask one of us to check it if you're not super confident on it. If you're super confident on it, just go to the next problem and try to do the next problem. And here's the domain range for the next problem.